Distinguished viewers all over the world, welcome once again to Simplified Maths Class. I am your host, Mr. Mike Omini. But please, if you have not subscribed to our channel, Simplified Maths Class, kindly do that by clicking on the red subscribe and on the bell notification. And God bless you as you do that. All right, today I bring to you the topic, standard form. All right, without waste of time, what is standard form? How is a number expressed in standard form? Now, a number is said to be in standard form if it is expressed in the form a times 10 raised to power n. All right, if a number is expressed in that form, a times 10 raised to power n, it means that number is in standard form, where our a is all right, so our a is the number from 1 to 9.9, meaning that whatever number is given, you are to move the decimal point to a position where the number will either be 1 point something, 2 point something, as the case may be, to 9.9. So your a will never exceed 9.99. Please take note of that. So it means a will always be a number in one significant figure. It will be expressed in one significant figure, 1 point or 2 points or 3 points or 9 points. Please take note of that. All right, so 10 here is a constant. So when you express a number in standard form, there will always be 10 in that expression. And then n is a negative or positive integer, whole number. So don't forget that. It means our n will be a negative or positive whole number, depending on the type of number that has been given for you to express in standard form. Let's have some illustrations so that you understand. A question might come, express the following. Express the following in standard form. All right, so we've been given, let's say, a 9. Express 9 in standard form, or let's take 9,000. Then b 387.5. c 4.29. d 287,000. All right, so we want to express all of this in standard form and maybe just 7. How do we express the following in standard form? Let's quickly do that. So we want to express this in standard form. Solution. We've been given 9,000 we want to express in standard form, and we know that for you to express a number in standard form, the number will be in the form a times 10 raised to power n. That's how you express a number in standard form, a times 10 raised to power n. Now, but what is our a in this situation? Our a will be, move the decimal point wherever it is and place it after the first significant figure. The first significant figure is 9. The decimal point for 9,000, if you press 9,000 even on your calculator, you see that the decimal point is at the extreme end. Please take note of that. So for 9,000, a number without a decimal point, the decimal point is at the end. All right, so we'll move the decimal point from here to this point. So that gives us our a to be 9 points. All right, so it becomes 9 point that. We've moved it to after the first significant figure, so that it will lie between 1 and 9.9. And of course, you can see that 9 lies between 1 and 9.9. And after the decimal point, understand that zeros are always useless. After the decimal point, they don't make meaning again. All right, so our 10 is constant, it is 10. And our n is the number of times we've been able to move the decimal point. Remember that the decimal point was previously here, so we moved it 1 time, 2 times, and 3 times. So our n is 3. We moved it 3 times. N is 3. Therefore, to express 9,000 in standard form, in the form a times 10 raised to power n. Alright, so our 9,000 will be equals to, a now becomes 9.00, which is 9. Alright, so that will be 9 times 10 raised to power n, which is 3, which is the number of times you move the decimal place. So it means that your 9,000 expressed in standard form will be 9 times 10 raised to power 3. Please take note of that. That's how we express a number in standard form. We want to express 387.5, all right, to standard form. We want to express that number in standard form. All right, so we also say that 8 times 10 raised to power n. Our a now will be equals to, we'll move the decimal point and place after the first significant figure. So we'll move it from here to come to this place. So we are going to have 3.875. 3.875. We have moved the decimal point and positioned it after the first significant figure. And of course, your 10 is 10, is constant, and n is the number of times we move the decimal point. So we moved it 1 and 2. So n is 2 because it has been moved 2 times. So it means that if you are to express 387.5 to the form a times 10 raised to power n, it will simply be 387.5 will be equals to 3.875 times 10 raised to power n, which is 2. So we've been able to express that in standard form. It's so simple. All right, so we'll take the third one. We want to express in standard form the third one. All right, so we have number I, which they say we should express 4.29 to a number in standard form. I. 4.29. We want to express that in standard form. Of course, we want to express in the form a times 10 raised to power n. Our a means we move the decimal point and position it after the first significant figure. And already it has been positioned after the first significant figure. So we still have 4.29. It won't change because the decimal point is where it is supposed to be in standard form. And then 10 is a constant, and n is the number of times we have moved. Have we moved the decimal point? No, it is still where it is. So it means our n is 0. We have not moved it. It therefore means that if you are expressing 4.29 to the form a times 10 raised to power n, it will simply be a is 4.29 times 10 raised to the power of 0, since we didn't move the decimal point. So we've been able to express 4.29 in standard form to be 4.29 times 10 raised to the power of 0. So let's take the next one, number 4. So we want to express 287,000 into standard form, or in the number in standard form. So we want to express to a times 10 raised to power n. Our a is to position, all right, the decimal point after the first significant figure. So that will be 2.87000. And of course, after the decimal point, zeros at the end are never useful again. So take note of that. Now 10 is a constant, which is 10. And n is the number of times we have moved the decimal point. All right, so we've moved it from here, where originally it is. Any number that does not have a decimal point has its decimal point at the end. So we've moved it from here, 1, 2, 3, 4, and 5. So we've moved it 5 places. So our n is 5. It means that to express 287,000 to a times n raised to power n, that's in standard form, we are going to have that 287,000 will be 2.87. The zeros are not important, times 10 raised to the power of what? 5. So we have expressed that in standard form. Okay, so we want to express the last one, 7, in standard form. How do we express 7 in standard form? 7 in standard form. So the D part, or the fifth one, 7 we want to express in standard form. So our A will be to position the decimal point after the first significant figure. And of course, 7 itself has its decimal point at the end of 7. And of course, you're not going to move it again. It will still be there, 7 points. 7 points, all right? It's still after the first significant figure. So the decimal point remains where it is. 10 is your constant, and n is the number of times you move the decimal point. And of course, we have not moved the decimal point. It remained where it is, so n is 0. So for us to express 7 in the form a times 10 raised to power n, 7 will simply be a is still 7 times 10 raised to the power of 0. Please take note of that. It's that simple. So 7 expressed in standard form with 7 times 10 raised to the power of 0. All right. So what about numbers, that begin with 0 point? Numbers that are fractions that are less than 1. That's numbers that begin from 0 point something. How do you express them in standard form? So that takes us to the second part of it, which is to express, decimal fractions that are less than 1 to standard form. They come this way. Number 2, so express in standard form I 0.00058 II 0.029 III 0.8 and IV 0.0000006. Want to express this in standard form. How do we handle that? Solution. So we have the first one, 0.00058. We want to express in standard form. We want to express in the form a times 10 raised to the power of n. What is our a? Our a is to position the decimal point after the first significant figure. And of course, the first significant figure here is 5. The second is 8. So we'll position this point after the first significant figure. Once you do that, you're going to have 5.8. So we'll move it to here. And of course, the 0 cell will no more be important again. So it becomes 5.8. And now the 10 is a constant, which is 10. And n is the number of times you have moved the decimal points. All right, so it was previously here. So we have 1, 2, 3, and 4 to become 5.8. So we've moved it to 4 times. But because this time around we are moving the decimal point anti-clockwisely, it means it becomes -4. We are taking it backwardly. In the other previous one, if we are moving the decimal point to the front, it means we are moving in the positive direction. But this time we are moving it to the backwardly. And that's why our n is negative this time around. So for all decimal fractions less than 1, their n will always be negative. -4 times. So it means that 0.00058, if it is expressed in standard form, in the form a times 10 raised to the power n, it will simply become 5.8 times 10 raised to the power of n, which is -4. So that's how you express that number 0.00058 in standard form. It's so simple. All right, you must know how to express, because sometimes a question comes, a challenging question in maths, and after solving they say express your results in standard form, and most senior students do not understand how to express numbers in standard form, because probably they learned it a very long time ago and they are forgotten. And I'm here to make sure I remind you of every important concept you will meet in your way climbing up, in your way of becoming a mathematician. I'll remind you of all them. All right, so we have that. So that's I part. So we want to take the second one, II. We want to express 0.029 in the form a times 10 raised to power n. And of course, our a is going to be to move the decimal point and position it after the first significant figure. All right, so that will be 2.9. Your 10 is a constant, and n is the number of times you have moved the the decimal point backwardly. All right, so we are going to have 1 and 2. So that will be -2 because we are moving it in the backward direction. So take note, so expressing 0.029 in the form a times 10 raised to the power n will simply be 2.9, which is a, times 10 raised to the power of n, which is -2. So we have expressed that in standard form. Please take note of that. All right, so we want to take the third one, 0.8, to express in standard form, 0.8. How do we express 0.8 in standard form? That leads us to I, number 3, 0.8. Let's express in standard form. 0.8. We want to express in the form a times 10 raised to the power of n. So our a will simply be to position the decimal point after the first significant figure. So it moves, it becomes 8 points. And of course, 8 points, no need of showing the point. 8 points. So we'll move it to the first significant figure after the first significant figure. That becomes 8 points. But we don't need the point. So 10 is constant and n is the number of times you move the decimal point backwardly, and that's just 1 time. So that will be -1. So expressing 0.8 in the form a times 10 raised to the power n, your 0.8 will simply be a is 8 times 10 raised to the power of n being -1. So we have expressed that in standard form. And then the last one we want to express, number 4, is 0.00000, okay, before 67. We want to express that in standard form. So expressing in the form a times 10 raised to the power n, our a will be to move the decimal point and position after the first significant figure, and that will be 6.7. And anytime your a is defined, just know that the a will always be between 1 and 9.9. It won't exceed 9.99. It will always be within that range, and that's what you are seeing for a. So your 10 is a constant, which is 10, and n is the number of times you move the decimal point. All right, 1, 2, 3, 4, 5, 6, and 7. So that is a -7. It is moved backwardly 7 times, -7. But please understand, anytime you have the decimal fractions that are less than 1, if you want to know the n, the number of times you're going to move, the number of times you're going to move the decimal point, which is defined as n, always count the zeros. The zeros will tell you. So simply count how many zeros do we have. 1, 2, 3, 4, 5, 6, 7. It means n will be -7. Here, if you count 1, it means n will be -1. Here, if you count 1, 2, n will be -2. If you count 1, 2, 3, 4, n will be -4. So you can actually know that by counting the entire zeros before the significant figures. All right, that's a shortcut. But of course, I have to show you the right thing that has to be done. You should understand that even expressing a number in standard form, sometimes you'll be asked to express back these numbers in standard form to the ordinary form. We can be able to express them to the ordinary form. Okay, so let's do that. So we have this. So it means that 0.0067 expressed in the form a times 10 raised to the power n will simply be 6.7 times 10 raised to the power of -7. So we have expressed that in standard form. Okay, what if you want to reverse these numbers expressed in standard form back to their original form? You can be able to do that. Let me just give you 1 or 2 or 3 examples so that we can be done. You see how easy it is to do it. So here we are done expressing numbers in standard form. Let us now express numbers in standard form to their ordinary form. Express the following numbers in standard form to their ordinary form or to their original form. Okay, so let's say A, we want to express 2.86 times 10 raised to the power of 5 back to the original form. B, 5.8 times 10 raised to the power of 0. C, and then D, we want to quickly express these numbers back to their original form. Let's say E. Let's express them back to their original form. Solution. Please watch out how we are going to do that. So the A part, we have 2.86 times 10 raised to the power of 5. We want to express back to their original form. So we are going to have this to be equals to 2.86 times 10 raised to the power of 5 is 1 with 5 zeros. 10 raised to the power of 5 is 1 with 5 zeros. Alright, so we simply multiply this by this. So that will become, now the first 0 to go, this will move 1 time. For the second 0, this will move 2 times. Please take note of that. We want to express. You can simply use your calculator to times it out. But I want to explain something. You're going to have 286 with 3 zeros. So this is the ordinary form it is expressed in. How did I get that? Alright. By the time I move the decimal point here 1 time, 1 0 is gone. Let me show you. 2.86 times 10, 1, 2, 3, 4, 5. So if I move the decimal point from here to this point, 1 0 will be gone. Alright. If I move it from here to here, another 0 will be gone. And then you are left with 286 times in 1000. And of course, 286 times in 1000 will simply be 286 with how many zeros? 3 zeros. And that's what we have here. So take note of that. But understand that 10 raised to the power 5 is 1 with 5 zeros. And multiplying that with 2.86 will definitely give you this. So you have expressed it in the original form. Then the B part, we want to express back 5.8 times 10 raised to the power 0 in the original form. So this is going to be 5.8 times 10 raised to the power 0. Anything you raise to the power of 0 according to the law of indices will give us 1. So 10 raised to the power of 0 is 1. And 5.8 times 1 will still give us 5.8. So expressing 5.8 times 10 raised to the power 0 to the ordinary form, you still have 5.8. So that's how it is. So we are taking the C part. In the C part, we have 2.8765 times 10 raised to the power of 2, which of course it is 2.8765 times 10 raised to the power of 2 is 1 with 2 zeros. That's 100. Okay? So of course, I've told you, for 1 0 to go, it comes here. For the other 0 to go, it goes here. So at the end of the day, you're going to have 287.65. That will be your final answer. So if you take 2.8765 and you times by 100, you should have this. So this is the original number that when expressed in standard form, it will give you this. Please take note of that. So what I simply do is, for 1 0 to go, I move it 1 decimal point. For the second one to go, I move it another decimal point. So it becomes 287.65. Or simply times that by 100, you will still get this. Alright, so the D part, we want to try the next one. 5.2 times 10 raised to power minus 4. So we are having minus here. So how do we do that? The D part, where we have minus. Please watch. So the D is going to be 5.2 times 10 raised to the power of minus 4, which means 5.2 times 10 raised to the power minus 4, according to one of the laws of indices, is to be 1 all over 10 raised to the power 4. That's what it means. 10 raised to the power minus 4 is 1 all over 10 raised to the power 4. So which means we are going to have 5.2 times 1 all over 10 raised to the power 4 down here is 1 with 4 zeros. 10 raised to the power 4 meaning 1 with 4 zeros. So at the end of the day, we are going to have 5.2 times 1 will give us 5.2 all over 1 with 4 zeros. So this will now simply be, if we divide 5.2 by this, it will give you your answer, which of course, is going to be 0.00052. That will be your answer. If you divide this by this, this is what you have. But this is what I simply did. So if you have 5.2 all over 10 with 4 zeros, what it means is move the decimal point this time around backwards. We want to move it this way to the front. How many times? 4 times. So if I move it from here to here, that will be 1 time. Let's have plenty zeros. All right, so we want to move it how many times? 4 times. So have 1, 2, 3, and 4. So I cleaned it. So that would be 0.00052, which is what I have here. All right, but if you don't want to stress yourself, you simply divide 5.2 by 10,000. You will get this. It's as simple as that. So let's take the last one. Let's express E. 5 times 10 raised to the power minus 6 to the ordinary form. So this will be 5 times 10 raised to the power minus 6 is 1 all over 10 raised to the power 6. Like I said, one of the laws of indices. So this is going to be 5 times 1 over 10 raised to the power 6 is 1 with 6 zeros. 1 with 6 zeros is 10 raised to the power 6. Of course, 5 times 1 will give us 5 all over 1 with 6 zeros. And if you divide this 5 by 1 with 6 zeros, you are going to have 1, 2, 3, 4, 5. All right, so this is what you have. If you divide 5 by 1 with 6 zeros, that's 100,000. You're going to have this. But what did I simply do? It means I moved the decimal point how many times? 6 times to this other side. So from here, 1, 2, 3, 4, 5, and 6. That's how I move the decimal point. So you know how to do that. But if you simply divide, you still have this. So we've been able to express this number in standard form to the original form, to the ordinary form, which is this. So that's how you handle standard form, expressing numbers to standard form and expressing numbers from standard form to ordinary form. It's a simple one. You have to take note of it. It's very important as you're climbing up as a mathematician to have an idea about how to do this, because most answers in exam questions, they will ask you to express it in standard form. Thank you very much for watching our slide standard form. If you enjoyed our class, simply give us a thumbnail. If you have any question whatsoever to ask, please drop it in the comment section. And if you have not subscribed to our channel, kindly do that by clicking on the red subscribe and on the bell notification. Personalize the bell notification. God bless you. Until we meet next, I still remain your host, Mr. Mike Omeni. Have a wonderful day. Cheers.